This is lesson 3.2, parallel lines and transversals. In section 3.1, we learned about all different angle relationships when we had a transversal intersecting two or more lines. Now we're going to talk about what happens if the lines that were intersected were parallel. So for the corresponding angles theorem says if parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So in our picture, angle 1 would be congruent to angle 5 if my lines are parallel, which I know they are because of these marks. Also, angle 4 would be congruent to angle 8. 2 and 6, also 3 and 7. Alternate interior angle theorem also says if parallel lines are cut by transversal, then the alternate interior angles are congruent. So angle 3 would be congruent to angle 6, and angle 4 would be congruent to angle 5. We have the alternate exterior angle theorem. If parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So angle 1 would be congruent to angle 8, and angle 2 would be congruent to angle 7. Now it's going to be a little different. The consecutive interior angle theorem says if parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. So now angle 4 and angle 6 would add to 180, angle 3 and angle 5 would add to 180. And then the same thing for consecutive exterior angle theorem. They are also supplementary. So if it has the word consecutive in it, it's going to be supplementary, added to 180. If it doesn't have the word consecutive in it, we're going to be setting them equal. And don't forget, we still have our two original theorems and postulates we learned. The vertical angle theorem said vertical angles are congruent. Linear pair postulate said linear pairs are supplementary. So for example 1, we're just going to identify the angle pair as either congruent or supplementary and state the theorem that justifies our reasoning. So if I'm looking at angle 3 and angle 5, those are alternate interior angles. So I could use the alternate interior angle theorem to say that those are congruent. If I'm looking at 1 and 8 are consecutive exterior angles. So we can use the consecutive exterior angle theorem. And anything with the word consecutive in it is going to be supplementary. 2 and 6. 2 and 6 are corresponding angles. They're in the same position. So we could use the corresponding angle theorem. And that means that they're congruent. 1 and 7 are alternate exterior angles. So we could use the alternate exterior angle theorem. And those are also going to be congruent. Anything with the word consecutive was congruent. So now we're at 4 and 5, which are consecutive interior angles. So we'll use the consecutive interior angle theorem, and anything with consecutive is supplementary. 3 and 7 are another pair of corresponding angles. So the corresponding angle theorem tells us they're congruent. 5 and 6. This is a bit of a trick question because that's a linear pair. It's not one of the newer ones we're learning. So this is using the linear pair postulate. And remember, linear pairs are supplementary. And then our final one is 2 and 4. Also a bit of a trick question because those are vertical angles. So using the vertical angle theorem, we can say that they're congruent. In example 2, we're given the measure of angle 1 is 65 degrees. I want to find the measure of all the other angles in our picture and explain our reasoning. I'm going to try to relate them back to angle 1, but if I can't, I'll relate them to another angle. So angle 1 and angle 2 are a linear pair. So I'm going to use the linear pair postulate with angle 1. And I know linear pairs are supplementary, so 180 minus 65 is 115 degrees. Angle 3 is a vertical angle to angle 1. So I'm going to use the vertical angle theorem with angle 1. And since they're congruent, Measure of angle 3 would be 65 degrees. Angle 4 is another linear pair with angle 1. Which means it's also supplementary with angle 1, so that's 115 degrees. And then angle 5 is our first one not in this cluster. Angle 1 and angle 5 are corresponding angles. So we'll use the corresponding angle theorem with angle 1 to say it's congruent to angle 1. It's 65 degrees. Angle 6 and angle 1 don't have a relationship. So we need to relate it to one of the other angles we already found. Since I've already found 4 other angles, there's 4 other names for what we can do right now. I'm going to choose to do corresponding with angle 2. So when I write corresponding angles theorem, I'm going to write that I used angle 2 here. But just know that this answer could be a lot of different things. It's possible to get something different and still be correct. The value will not change though. Angle 2 and angle 6 the same, so angle 2 is 115 degrees. For angle 7, angle 1 and angle 7 are alternate exterior angles, so we'll use the alternate exterior angle theorem. So 1 and 7 are congruent, so angle 7 is 65 degrees. And then our final pairing, angle 1 and angle 8, are consecutive exterior angles. So we'll use the consecutive exterior angle theorem with angle 1. And that means they're supplementary, so that would be 115 degrees. So you can try check in 2. Pause if you'd like. The answers are posted online on Google Classroom. Example 3a, we're going to solve for x and explain our reasoning. So I usually like to do my explanation first because that tells me how I'm going to set up my problem. So 58 degrees and the 5x minus 2 degrees are corresponding angles. So I'm using the corresponding angle theorem. And corresponding angles are congruent, so I'm going to set 5x minus 2 equal to 58. And now we're going to solve. I'll add 2. And I'll divide by 5 so that I get x is equal to 12. It's another one for us to do. So these 2 angles didn't have a relationship, but if you notice there's a number 4 here without a degree sign on it, that's calling it angle 4. And they do that for us so that we have a way to explain, right? They're telling us, kind of giving us a hint that we should be using angle 4. I know these 2 angles are congruent by the vertical angle theorem. And now that I know that the measure of angle 4 is 115 degrees because of the vertical angle theorem, my new angles are consecutive interior. So this required 2 reasons for why we're going to do what we do. And now that I'm using consecutive, I know that they're going to add to 180. So this is going to be x plus 120 equals 180, and x, if I take away 120 from both sides, equals 60. So here's 2 check-ins for you to try. Pause it if you'd like. The answers are posted online. In example 4, it's the same as we really had for example 3, but now there's 2 variables. So I'm going to focus on the 2 that have the same variable first. There's an x in this corner and an x in this corner. These angles are alternate interior angles. So I'm going to start with the alternate interior angle theorem. And I'm going to say that 8x minus 31 is equal to 6x plus 3. So I'm going to take away 6x from both sides. I'm going to add 31 to both sides. And now I'll divide by 2 so that I get x equals 17. The second part, there's actually 2 different ways we can do it. I can choose to use the 6x plus 3 and the 5y plus 35 as consecutive interior angles, or I could use the 8x minus 31 and the 5y plus 35 as a linear pair. I'm going to go with the consecutive interior angles only because that is our new thing. So I want to make sure we're using as much new stuff as we can. So I'm going to use the consecutive interior angle theorem to say that these two angles, the 6x plus 3 and the 5y plus 35, are equal to 180. And since x is 17, I'm going to substitute that in. So if I do 6 times 17, I get 102 plus 3 plus 35. So adding together all of that, I get 140. Take away the 140. So now 5y equals 40. And when I divide by 5, I get y is equal to 8. So here's one for you to try. Pause it if you'd like. The answer is posted online. And now we have proofs. So this proof, we are given that we have parallel lines. And as soon as I know I have parallel lines, I know I can now use any of my new relationships. So I'm going to fill in my given here, and I'm going to check to make sure my proof statement is there. It is. So that's all I can do so far. So now I'm saying angle 1 is congruent to angle 6. And if I look at the picture, we're going to have to look at the pictures quite a lot more now. If I look at the picture, 1 and 6 are vertical angles. So that's the vertical angle theorem. Then it says I'm using the definition of congruence. So if I take the two angles that I knew were congruent, I can now switch them to say that they're equal. Then I have angle 6 and angle 7 are supplementary. And if I look at the picture where 6 and 7 are, those are consecutive interior angles. So that's the consecutive interior angle theorem. And using the definition of supplementary, I know that these two angles should add to 180. Now I want to use substitution. The only equation I've had is that the measure of angle 6 plus the measure of angle 7 is 180. And I'm substituting in 1 and 6 are the same. So I'm going to change 6 to 1. And my last step is saying that 1 and 7 are supplementary. And I'm saying that because I knew they added to 180. That's the definition of supplementary. So there's one last problem to do. Pause it if you'd like. The answer is posted online. But that is the end of section 3.2.